Now friends, we want to reverse the question a little bit. Okay friends. So here we were always calculating the future values, right? Now our question is, let's say there is a bank ABC which provides FD for 5 years at the rate of 12% annually. At the end of 5 years, you want the future value of your investment to be $1,000. At the end of the 5 years, you want your future value of investment to be $1,000. So the question is, how much should you invest now, or what is the present value you should invest in this kind of a scheme? So we already know friends the formula for future value. FV is equal to PV multiplied by 1 plus R raised to the power n. Now we want to know what is the PV. So PV is equal to FV divided by 1 plus R to the power n. As simple as that. So this is equal to 1000 divided by 1.12 raised to the power 5. Let's calculate the value friends. 567.4268 or 4269 approximately. This is the investment you need to make now to get $1,000 at the end of 5 years in this scheme, 5 years at 12% that your bank ABC is providing. Right friends? So this is how you calculate present value when your future value, compounding rate and compounding periods are given. Now we'll complicate this a little bit more. Let's say bank ABC is providing another FD for 3 years. And this is at 10% annual rate, compounded quarterly, right? What is the current investment for you to get a future return of $5,000? So you want to get $5,000 at the end of 3 years from this scheme. How much should you invest now? What is your present value to be invested? How do you calculate this friends? This is also very simple. PV is equal to FV divided by 1 plus R divided by periodicity. This entire expression raised to the power of n into periodicity. So here we know all the values. 5,000 divided by 1 plus R is 0.10 or 10% divided by periodicity is quarterly. So divided by 4 raised to the power of number of years 3 into periodicity, which is 4. So this is equal to 5,000 divided by 1.025 raised to the power of 12. We can easily find out the value friends. 1.025 raised to the power of 12. 5,000 divided by this value. This is equal to 3717.78 approximately. This is equal to 3717.78 approximately. Right friends? So here we go. What if this compounding was continuous friends? What if this compounding was continuous? How will we calculate this? Let's look at that. ABC Bank has a fixed deposit investment scheme for 3 years where they give you a return of 8%. And this is annual return compounded continuously. Now you want at the end of 3 years you want to have $2,000. How much should you invest now? This is the question friends. How do we calculate? Very simple friends. We know that in case of continuous compounding, FV is equal to PV multiplied by exponential raised to the power of the annual return multiplied by the number of periods, right? So PV is naturally FV divided by this expression, exponential raised to the power of R into N. Here we know all these values, right? Future value we want is $2,000. Exponential raised to the power of 0.08 multiplied by 3. So this is, we can easily calculate 0.08 into 3 raised exponentially. This value divides 2000. 1573.255. Approximately. $1573.255 approximately we have to invest now to get $2,000 under this scheme. 3-year 8% compounded continuously. So this is the way we do the calculation, friends. Now friends, we will learn a couple of new concepts. The first concept that we'll learn is effective annual rate. Now what do we mean by this, friends?